Okay, so part 2, we're going over g of x equals -1 plus 2 cosine pi x minus pi over 2 periods again. So like I said in the previous problem, if you haven't watched the video yet covering -3 sine of 2x minus pi plus 1, I suggest you watch that video first because this video is intended for you to practice trying to graph this on your own and then going through the video to see how it's done. Okay, so just like before, the first thing that we want to start off with here is setting what's inside, let me change the color here. We're setting what's inside of our cosine function to be between 0 and 2 pi. So we have 0 is less than or equal to pi x minus pi, and it's less than or equal to 2 pi. Remember, we always use this interval when we're dealing with sine or cosine. So if we go about solving this, we're going to add pi to all three of these, which gives us pi is less than or equal to pi x, which is less than or equal to 3 pi. Now from here, we want to then divide all three of these by pi, which ends up giving us pi divided by pi, which is just 1, is less than or equal to x, which is less than or equal to 3. 3 pi over pi gives us 3. If you look in the previous problem, the interval that we ended up getting was pi over 2 to 3 pi over 2. But in this case, we're just left with standard constants, just 1 and 3. We don't have any pi's. And that's because we ended up having to divide by this pi in front of our x. In general, that'll usually end up happening whenever there's a pi in front of your x. Not always, but just typically. So now we need to go about finding our period p, which like always when we're dealing with sine and cosine is 2 pi over b, and b in this case is again this pi that's in front of our x. So 2 pi over pi gives us 2. Our period is a distance of exactly 2. So just like before, we then want to find p over 4, which is 2 over 4, or just simply 1/2. So our quadrantal angles, our new quadrantal angles essentially, are going to be starting at 1, ending at 3, and a distance of 1/2 apart. So with that, we can then make our table using our x values and finding our cosine of pi x minus pi values. So we start with our first x value, which is 1. And remember, we add p over 4 to it 4 times, so we're going to add 1/2 to it 4 times. We get 1 plus 1/2 is 3/2. 3/2 plus 1/2 is 2. 2 plus 1/2 is 5/2. And 5/2 plus 1/2 is finally 3. And again, we just do a quick check to make sure we've done this correctly. We start at 1, we end at 3, which is exactly what we needed over here. So we do have our correct period. And now in this case, we're dealing with cosine. Remember, when we deal with sine, we always get 0, 1, 0, -1, 0. When we deal with cosine, we always get 1, 0, -1, 0, 1. Again, you could just plug these x values into your x here to get those values, but you can just commit this to memory. These will always be the values you'll get if you've done this correctly. And now we can create our list of transformations. Remember, this will be our new parent function essentially. It takes into account all of our horizontal transformations. Now we just need to list all of our vertical transformations. So for our first transformation, we do not have a vertical reflection because this is a positive 2 being multiplied to cosine, which means our first vertical transformation is going to be the 2 that's being multiplied, which represents a vertical stretch. Again, remember, if it were between 0 and 1, then it would be a vertical shrink or compression. From there, we then want to take care of the 1, or in this case, -1, that's being added to the outside of our cosine function, which means we are shifting down a distance of 1 because it's negative. And these are the only 2 transformations we have to worry about. So we can start graphing this. Remember, we first need to label. We need to label all of these points. We need to label their tick marks on the graph, and then we can start performing our transformations. So our x values need to start at 1 and finish at 3. Our y values need to bounce between -1 and 1. So on this graph, if we were to consider each of these tick marks to be 1/2, then we would have 1/2, 1, 3/2, 2, 5/2, 3, which works perfectly for our graph. So we're going to label our last one 3 to show its final distance, and our first one 1/2 to show what each tick mark represents. It's even better if you label every single one of these, but in this program that just would take a long time. That's why I'm just showing the first and last. So now let's plot these points. We have 1, 1 right here. And we'll make a quick note that this is a distance of 1 on our y-axis. This is a distance of -1. Then we have 3/2, 0 right here. 2, -1, which is right here. 5/2, 0. Oh, I apologize. I started at 1/2 instead of 1. So we're just going to do a quick fix there. So instead of at 1/2, we needed to start at 1, 1, which is right here. Then 3/2, 0. Then 2, -1. 5/2, 0. And finally 3, 1, which ends up giving us our general shape of cosine, which, remember, it's not a V, it's more like a U. It's got a curve to it, not just straight lines. Now we can take care of our transformations, which gives us first our vertical stretch, and our vertical stretch is by a factor of 2, which means all of our y values are going to be multiplied by 2. So for instance, this point has a y value of 1, which means it's now going to have a y value of 2. This point has a y value of 0. If you multiply that by 2, it remains 0. This -1 will become -2. This 0 will stay 0. And finally, this 1 will become 2, just like before, which gives us a new graph that looks like this, a much taller or longer U. And now finally, our last graph will be in blue, just like before, and it's going to be a shift down 1. So every point on our red graph is going to move down 1. So this point will go back to where it started essentially. This point will shift down 1, down to -1. This -2 will go down to -3, which we'll make a note of here. This 0 will go down to -1. And finally, this 2, which we'll make a note of here, will go down to where it originally started, at 1, which gives us a final graph that looks something like this. It doesn't have to be perfect, just a general sketch. And now finally, remember that this graph is over 2 periods. So we need to take this entire thing and shift it to the left or to the right, a distance of 2, because remember, our period is 2. So in this case, I'm going to show you how to shift it to the right 2. It does not have to be perfect when you do this, just a general sketch. So I'm just going to redraw this U as close as I can to the right, which is going to end up looking like this. And that gives us our second period of our graph. I didn't edit out this mistake that I made earlier where I started at 1/2, because I want to show you all that when you're going through this, if you notice your last point is going to end up not where it should be, so how we were supposed to have a point at 3, 1, and my point, if you remember, would have been at 5/2, 1. That's a general idea to know that you're doing something wrong. Something is going wrong. Even if it's not matching, even if it is matching up in your table, make sure it's matching up in this interval as well. These are a bunch of checks that you can go through to make sure your final answer is working correctly. But this is our final graph. And like always, we want to label it with our final function name, which in this case was g of x.